For my last example here on day 5, example 6, I've got f of x equals x squared minus 4 on the top over x minus 2. I should factor right away. Luckily, this factoring is easy. It's difference of squares, so x plus 2, x minus 2, all over x minus 2. And hopefully you'll now see why I chose this as my last example, because I have x minus 2 as a factor on the top polynomial and the bottom polynomial. Because of that, I know that these are going to cancel, and I'm going to get a whole. I'm going to get a whole at the root of this. So the root of that is at x equals 2. The problem is going to happen when I put 2 into that equation. So there's going to be a whole at 2. And because it cancels, all I'm left with is just x plus 2. So this is just a line. The line is y equals x plus 2. I really don't need any other information. I know how to draw that line. If you really wanted, you could get the y-intercept is 2. You know that. The x-intercept is when y equals 0. Excuse me. So the x-intercept's at negative 2. But I don't think I need that information. I can draw this graph. I know that x equals 2 is up 2, and it goes up 1 over 1, up 1 over 1, up 1 over 1. And look, it's going through those two asymptotes at negative 2 and 2. Or sorry, 2 intercepts. And I'm going to draw my line. Nope, that wouldn't go very well. I should take my ruler, of course, and draw this line. So I have that. The only catch is, sure, it's the line y equals x plus 2, but it's got a hole, and my graph doesn't have a hole. The hole happens when x equals 2. So I'm going to erase my graph at x equals 2. I'm going to erase this little spot because there's going to be a hole there. And the way we signal that there's a hole is we're going to have an open circle. We did this before when it comes really close to but doesn't equal to. Oops. And now I have this graph. So it's a graph y equals x plus 2, except it has a hole at the x value of 2. And you see there's your x value of 2, and so it has to have a hole right there. It's not an asymptote. It seems like an asymptote, but it's actually just a hole in this case. So there's our last example of a rational function that might end up happening with some holes. This would be great if it did, because it's the easiest of all of them, but we know that most of the time is going to be like the graphs we had before. So the rest of the time you now have is to do some practice. So you can go to your worksheet, and you may or may not have already been assigned these. So there's a bunch of possible ones. I would choose numbers from 23 to 45. Only do the odd ones, so like 23, 25, 27. I do have answers for all of those ones. I don't have answers for the even ones. And I've added a couple at the bottom. So if you add example number 47, 49, and 51, these are all ones that have holes in it. The ones on the worksheet don't have any holes in them. So you should have the rest of the period to practice this, and we will have some other times in class to do some more practice as well.